Hi there. Let's deal with the concept of predator-prey cycles today. Predator-prey cycles are very important for us to understand the health of an ecosystem, and I'm going to tell you why. First of all, predators in an ecosystem are animals that eat other animals for food, so they're either an omnivore or probably a carnivore. Mountain lions, wolves, and they have these huge eyes to help them spot their prey. Sharp teeth, claws, and prey, of course, are animals that are eaten by the predators. Mule deer, rabbit. Herbivores are always prey. They have flat teeth. They have feet to try and be well adapted for running. And they have eyes so they can see a wide range when they turn their head. Some animals can be both predators and prey. For example, the Texas horned lizard is a predator when it eats ants, termites, beetles, and grasshoppers. It's also prey when it's eaten by snakes and so on. The reason we study predators and their prey is there is a distinct pattern that will happen in a healthy ecosystem between the number of predators and the number of prey. It's very predictable. It follows a nice, neat pattern over and over again over time. So let's look at that pattern so that we can recognize it on graphs. Here's our prey, the number of lynx, and here's our predators, the number of snowshoe hare. And we've graphed the numbers of these organisms over time. And so the number of snowshoe hare peaks and then it starts to drop down and it reaches a peak somewhere around 2.5 years. And then the number of predators reaches a peak somewhere around 4 years. And then it starts to drop down and it reaches a valley. The number of prey reach a valley and then they start to go up again. This up and down of predators and preys will always occur, and what will usually happen is you'll get a peak in the prey population followed slowly by a peak in the predator. Peak in the prey, peak in the predator. Prey peak, then predator peak. Prey crash, predators will follow. Prey crash, predators will crash. Why is that? Well, as time goes on, as the years go on, the number of prey go up because there are less predators. As they start to go up, the number of predators will start to rise because there's more food available for them to eat and reproduce. But pretty soon, there's a breaking point where over time, there's so many predators that the ecosystem can't handle it anymore due to space. There's a finite space, and the prey will start to crash and they'll go down. Well, that's going to cause a crash in predators because now there's less prey around to eat. And so they'll crash and it'll go over and over again in a nice, neat little cycle. Here it is again. Peak, 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 peak. So a peak in the prey followed by a peak in the predator. Peak in the prey followed by a peak in the predator population. Follows a nice, neat cycle. And that's only if the ecosystem is healthy. If there's a disease in the ecosystem or a hunter comes in and starts poaching some of the predators, then it won't follow this cycle and then we have to be worried about the ecosystem. For example, let's look at this predator-prey graph. There's lots of instances where it doesn't follow this pattern that indicates things are going fine. Let's follow the prey. So we get a peak in the prey, followed by a peak in the predator. But then look what happens. Something funny happens here. It doesn't follow that pattern. What went wrong? We're not sure. We'd have to look closely at the ecosystem. Then we get a peak in the prey, followed by a peak at the predator. That's good. peak in the prey, followed by predator. But again, look at there, that something funny happened there. Peak in the prey, peak in the predator, peak in the prey, peak in the predator, that's good. Peak in the prey, peak in the predator, peak in the prey, peak in the predator, peak in the prey, peak in the predator. So a couple instances here where something went wrong in the ecosystem. There's another one right there. Okay, and so if that's the case, like I said, maybe poaching, a disease hit one of them, etc. So interpreting and following predator-prey relationships over time really helps us study an ecosystem carefully. What goes up must come down. What goes up must come down.